Okay, in this problem number 4, you see that these ions, glucose, sodium, and potassium, all will come to equilibrium. And so the three, these two will probably come to something, again, just for argument's sake, saying something like 1.5%, somewhere in the middle. This one will go up, this one will come down, and they'll meet somewhere in the middle, right? So let's say something like, 17% or something like that. And it'll probably be more like 16.5%, but in any case, 17%, and this one will come up, and this one will go down, so that's a difference of 2. So this will come down to probably something like 39%, right, on both sides, right? Now, on one side, you're going to have this sole 5% that's not going to change, and that's the starch because it can't get through the membrane. So there's, again, 2 ways you can do it. You can just focus on just starch because that's going to be the big difference, and knowing that no matter how much, because all of these will be equal, all 3 of these will be equal concentration in the end because they're permeable. The only difference between outside and inside is going to be the one solute in this case that does not pass. And so inside you're going to have a higher solute concentration, lower water. And outside you're going to have a lower solute, higher water. Now, I personally like this idea of not having to calculate the percent water because it gets a little confusing when you do. So knowing that you have higher water on the outside and lower water concentration on the inside, hopefully what you're getting is that this water is going to move from high to low, and therefore the water will move into the cell. Meaning, therefore, the cell will swell, right? Will increase in size as more and more water goes in. So I hope that made sense. Let's go on and move on to problem 5. Here we're at problem 5 now, and you're going to see this very similar, same final processes, except they throw in a little bit of a twist. So 5% glucose, they have 25% starch. Starch doesn't move, glucose does. 20% glucose, 20% potassium, and 10% iodine. Now, the first question comes again, and this question keeps coming up over and over again, is what crosses the membrane and what does it? And you see iodine does cross the membrane. And so iodine crosses, potassium crosses, glucose crosses. The only one that's not crossing is starch. Now, the other thing that we know is that according to the problem, right, iodine is a yellowish solution. A starch solution is white. The starch will turn purplish black in the presence of iodine. Okay? So iodine itself is yellowish. Starch is white. If this is permeable, so as this solution goes into this solution, we expect that inside it's going to start to turn, change color, right? It's going to turn to some kind of purplish black. Why? Because this is permeable, right? So, and also, do you expect water to go into the cell? For sure, water will go into the cell because, again, these particular solutes are going to find equilibrium. This solute is going to rush in until it finds equilibrium. So is iodine is going to rush in until it finds equilibrium. Water, on the other hand, because when you look at the total concentration of solutes, these will all be at equilibrium. In the end, it's only starch that will find itself out of sorts. So water will end up going from where it's high water concentration, low water concentration, and by this time you should be able to figure out that why we know that water is a lower concentration inside, water will go from high to low, and the cell will swell. It's just that simple. All right.